Imagine handing over the keys to your entire digital life. You ask an AI to, tidy up your workspace, and it gets a little too enthusiastic.
Yeah, that's never good.
Right. And in a fraction of a second, vital files weeks of hard work are just gone. It is not a sci-fi hypothetical. It is happening to developers right now.
It really is a terrifying scenario. I mean, you are giving an autonomous agent access to your actual machine.
Welcome to the deep dive. Today, we are exploring the edge of your digital workflow. Specifically, we are looking at 5 free open-source plugins for Claude Code.
And these tools, they're incredibly practical. They bridge a really crucial gap. They take a powerful raw AI model and make it safe. More importantly, they mold it to fit your actual daily workflow.
We have a lot of complex ground to cover today. We will look at stopping AI from deleting your workspace. We'll discuss the underlying math of making your apps look less like generic templates.
Which is huge.
Yeah, we are going to strip out the statistically average robotic writing. And finally, we will force the AI to respect your cognitive load and get straight to the point.
It is entirely about control. We are moving away from adapting to the AI. You are shaping the AI to work for you.
So let's start with this concept of a secure workspace. Before we can build anything beautiful, we need safety. We have to make sure the AI does not accidentally destroy our infrastructure.
Right. And to understand why this happens, we have to look at how Claude Code actually operates. It is powerful because it interacts natively with your terminal.
Yeah.
It reads files, writes files, and executes bash commands.
But an LLM doesn't really possess spatial awareness. It doesn't actually know what a file represents in the physical world.
Exactly. It just sees a string of text.
Yeah.
It executes based on probabilistic next token generation. So if you ask for a routine cleanup, you might just want to delete a few old cache files.
But the AI chooses a much more destructive command. It completely misinterprets the scope of your request.
There is a very real cautionary tale from X about this exact failure mode. A user gave Claude Code access to an AWS account. It was supposed to be restricted to a specific lab environment.
But the AI hallucinated the boundary of that environment.
Yeah, things went completely sideways. Claude Code ended up executing a command that deleted an entire S3 bucket.
Wow.
And that bucket was completely unrelated to the intended project. Beat.
That gives me profound anxiety just hearing about it. It's like having a co-pilot who is absolutely brilliant, but way too eager. You need a system that physically forces them to ask for the launch codes before they hit the big red button.
That is the perfect analogy, and it is exactly what the destructive command guard plugin does. It acts as a mandatory safety middleware.
How does it actually intercept the AI? I mean, if the AI is typing in the terminal, how does the plugin stop it in time?
It uses something called a hook.
Which is what exactly?
Just a background check before the computer runs an action.
Okay, so it sits between the AI and the operating system.
When Claude Code prepares to run a shell command, it sends an API call. The destructive command guard effectively intercepts that API call to your OS. It parses the command line string.
So it is scanning for specific, highly destructive syntax.
Right. It recognizes things like the ARM-RF flag, which forces a recursive deletion, or in the AWS case, Oz S3 for removing a ducat. When it sees those, it suspends the execution thread entirely.
It blocks the command before the operating system even registers it.
Yes. It flags the dangerous command, then it pauses everything and asks you for manual approval on the screen.
So it doesn't rely on the AI catching its own mistakes.
Yeah.
The AI is entirely out of the loop at that point.
Exactly. You can reject it completely, you can choose to run it yourself, or, well, you can allow it if you truly meant to delete those specific files.
I imagine this is absolutely crucial for client repositories. You want that extra firewall before the AI touches sensitive client infrastructure.
It is vital. And the technical elegance here is that it works separately from the model. It does not use any extra tokens.
Let's define that quickly. Tokens are basically the computational currency the AI uses to process text.
Yeah, and saving them really matters. It keeps costs down and preserves the AI's short-term memory or context window. Because the guard runs locally on your machine, it doesn't waste any of that currency.
Does this extra layer interrupt the flow of coding too much?
Not at all. Routine, safe commands pass right through the middleware without any pausing.
Got it. So it only hits the brakes for the truly dangerous stuff.
Safety first. Always. Now, once your workspace is genuinely secure, your mental focus shifts. You can start thinking about the actual architecture and design of what you are building.
Which brings us to the visual side of things. AI can build a functional front end incredibly fast, but there's massive catch.
The output almost always looks like an AI-generated design.
I still wrestle with prompt drift myself. I try to make UIs look original, but they always snap back to feeling, slightly generic.
You are definitely not alone in that. The underlying issue is that Claude Code defaults to familiar UI libraries. It leans heavily on standard Tailwind CSS patterns.
Because statistically, those are the most common patterns in its training data. It plays it safe.
Right. The product works beautifully, but it feels like a default template. Your end users feel like they have seen this exact dashboard 100 times before.
This is where a plugin called CanvasUI comes into play. It is a free open-source library. It is packed with 24 different shader components.
And this gets highly technical very quickly.
A shader is basically a small program calculating graphics effects pixel by pixel.
Shaders are incredibly difficult to prompt an AI to write from scratch. You can't just say, make it look cool. You need complex mathematical rendering logic.
So how does this plugin actually solve that?
These components are pre-built for web apps and SaaS products. They already contain the complex visual mathematics and fluid WebGL movement. CanvasUI gives the AI this mathematical scaffolding.
So instead of inventing the math, the LLM reads the provided shader code. It maps the specific variables in the shader to the user's React or Vue framework.
Right, and that bridges the massive gap between raw graphics rendering and your standard component tree. It doesn't replace the main structure of your app. It injects these nuanced visual details that a general text prompt struggles to create.
The sources outline a few highly specific components. Let's look at the bubble cursor.
Yeah, that adds a dynamic glass bubble effect. It mathematically calculates the velocity of the user's cursor. Then it smoothly drags a magnified glass distortion across the screen.
That has immediate tactile feedback.
Yeah.
And what about the hex float grid?
That creates a floating hexagon background. The shader calculates depth and shadows dynamically based on scroll position. It adds massive visual depth to an otherwise flat landing page.
There's also a dithered 3D object component.
That is a stunning effect. It renders a 3D model but applies a retro pixelated dithering filter over it. A single mathematical effect in a hero section can completely elevate the perceived value of a design.
Meng, too, actually demonstrated a brilliant use case for this workflow.
Yeah, he showed how developers can hand these Canvas UI components directly to a coding agent.
Instead of asking the AI to build a complex interaction from nothing, you provide the foundational component. Then you instruct the AI to wire it up to your specific database state.
It is a massive unlock for indie hackers or founders trying to ship an early MVP iteration. It helps the interface feel premium and bespoke before you even launch.
Can Claude Code actually implement these complex shaders on its own?
Canvas UI handles the heavy graphical mathematics, so the AI simply adapts the surrounding code.
Right. Claude just adjusts pre-built visual blocks to fit your exact design.
Exactly. It saves you hours of frustrating trial and error prompting.
Yeah.
But static beauty is actually quite fragile. We have to consider how the app feels when it's actively processing data.
That is a critical point.
Yeah.
You can have a breathtaking interface, but the moment a user clicks a button and nothing happens for 3 seconds, that premium illusion is shattered.
It breaks user trust immediately. The psychology of waiting is fascinating. When a background task takes longer than a few hundred milliseconds, a frozen interface generates real anxiety.
Users need visual proof that the machine is working. A standard spinning circle just doesn't cut it anymore.
No, it feels cheap. This brings us to the third plugin, animated UI components.
This is another free and open source collection, but unlike Canvas UI, this one focuses strictly on interactive states.
It maps directly to your application's loading states. When an AI agent processes data, the React state changes to ice bending. These components visually represent that specific state.
So Claude Code takes this ready-made animation code, it integrates it, and adjusts the colors and sizing to match your current layout.
Let's look at a specific example from the sources called Thinking Orbs.
This is specifically designed for AI applications. When the AI is processing a complex query, the interface reveals these fluid, glowing, animated orbs.
They pulse and interact with each other.
Whoa. Beat. It's amazing how a tiny visual cue, like thinking orbs, completely changes user trust. It makes the wait feel intentional.
It really does. The latency hasn't changed. The user still has to wait 3 seconds. But visually communicating that the AI is thinking reduces perceived latency drastically.
It provides necessary friction. Then there is the border beam component.
That maps a glowing light effect to the parameter of a specific div or container. It smoothly traces the border of a button or a pricing card.
That sounds like a powerful tool for directing user focus.
It is, and the third major component is liquid metal. It adds an undulating metallic sheen to areas requiring immediate visual attention.
Herbode actually deployed that liquid metal shader on a production project.
Yeah, he integrated it during the redesign of the EAS dashboard. It is a highly complex enterprise tool.
Which proves these aren't just isolated demo gimmicks. They perform beautifully inside real data-heavy products.
Are these animations distracting to the end user?
I would assume so.
Yeah.
But wait, do they actually pull attention away from the core data?
They actually guide the user's attention to important actions during empty states. They provide critical feedback.
Ah, so they act as visual anchors rather than just flashy distractions.
Precisely. They make your primary call to action impossible for the user to miss.
We are going to pause for a very quick moment. We will be right back with more on refining your AI workflow. 2-sec silence. And we are back. So far, we have secured our physical workspace in the terminal. We have elevated our static visual design. We have mapped complex animations to our loading states.
But a software product is ultimately driven by information. You have to consider the actual text.
Right. And what happens when the AI is tasked with generating copy for your interface or drafting onboarding emails? We all instantly recognize that statistically flat AI voice.
It is undeniable. You can give Claude Code a phenomenal prompt. It can follow your technical topic perfectly. It can get all the factual parameters right. But the resulting draft still sounds completely artificial.
It is an inherent flaw of LLMs. They regress to the mean. They output the most statistically probable sequence of words,
Which results in highly repetitive sentence patterns. The transitions are predictable. The conclusions always sound exactly the same.
Peter Yang recognized this psychological exhaustion. He got tired of reading the same predictable patterns everywhere. So he built our fourth plugin, No AI Slop.
I really love that name. No AI slot.
It doesn't leave much to the imagination. It is a free, open-source Claude Code custom skill. It actively hunts down and eliminates more than 20 common AI writing patterns.
It targets those generic, pseudo-profound openings we see constantly on LinkedIn. Phrases like, here's what nobody tells you.
Yes, or those forced structural contrasts. It's not X, it's actually Y.
It also ruthlessly hunts down empty transitional phrases. Things like, it's important to remember that.
And those formulaic summarizing endings, where it just regurgitates the entire point you just spent 5 minutes reading. But let me push back on this underlying philosophy for a moment. Is this just a sophisticated tool for trickery? Are we just trying to fool human readers into thinking another human wrote the text? Doesn't replacing robot speak with optimized human speak just create a new, equally predictable template?
That is a really valid critique. If everyone uses the same humanizer, the humanizer becomes the new slop.
Exactly. So does this actually make the writing objectively better?
It does, but you have to look at how it operates natively. It doesn't force a specific positive style. It doesn't tell the AI to sound like Hemingway. It is about removing the negative space.
So the focus is entirely on deletion.
Right. It targets named, empty cliches. It adjusts the AI's token probabilities to heavily penalize those specific robotic phrases. It is not about tricking the reader. It is about enforcing a much higher standard of editorial brevity.
Okay, that makes sense. It surgically removes the weak statistical filler, but it leaves the core informational density intact.
The real architectural power here is that it acts as a persistent system prompt. You don't have to constantly paste your customized humanizer rules into every single chat window.
You integrate the skill once, and Claude applies these editorial constraints consistently across every interaction, whether you are generating UI copy, release notes, or complex architectural documentation.
And if you already maintain a custom set of editorial guidelines, you don't lose them. Claude Code can intelligently merge the files. It injects the no AI slop rules into your existing system prompt.
Does this overwrite your own personal writing style?
No, you can seamlessly merge it with your own custom stylistic rules.
Makes sense. It strips robot cliches while keeping your unique human voice.
Exactly. It makes your product copy significantly sharper and much less fatiguing to read.
Okay, we have refined how the AI communicates with your end users. Finally, let's examine how the AI communicates directly with you, the developer.
This represents a massive friction point regarding cognitive load.
You ask Claude a highly specific technical question while deep in a coding session. It calculates the correct answer, but it buries the single actionable shell command under 4 paragraphs of excessively polite explanation.
It is incredibly frustrating. Context switching is computationally expensive for the human brain. You are trying to maintain flow state. You absolutely do not need a polite essay.
It feels like asking a university lecturer for a wrench. You just need the tool to fix the pipe.
Mm.
But you get a comprehensive history of metallurgy first.
That is why the fifth and final plugin has gained so much traction. It is called I Have ADHD.
This plugin essentially alters the attention heads of the model. It turns the AI into an efficient, silent sous chef. It hands you exactly the precise tool you requested right when you need it. 0 lectures.
That is a phenomenal way to frame it. It changes the fundamental output architecture. The most computationally useful information must appear on line 1.
It is built around 10 very rigid response constraints.
Rule 1 is absolute. Give the direct answer first.
It also forces Claude to strictly number multi-step terminal tasks.
It completely eradicates conversational introductions. It keeps bulleted lists extremely dense.
And it forces the AI to isolate one discrete action per step. It prevents the model from blending 3 different bash commands into one confusing block.
One of the most effective constraints is how it handles task completion. It demands a specific, logical next step. It explicitly forbids that generic, hope this helps, sign-off beat.
Jackie shared some highly relevant feedback on this in our sources. He noted that it drastically reduced his mental fatigue. The clear visual organization of sequential steps is a complete game changer.
If you are an engineer juggling complex deployments, this constraint is mandatory. It makes the next required action instantly visible. You don't have to burn mental energy parsing paragraphs of text just to find a single port number.
You can deploy it as a standalone skill, or you can merge it into an existing concise answer workflow.
Yeah, many developers rely on the /quick command architecture. If you merge them, typing /quick3 forces the AI to return exactly 3 bullet points of data. No more, no less.
And /quick5 works perfectly when the specific task requires a deeper technical breakdown.
Can this make the AI too brief, making it miss important context?
The /quick5 command allows you to explicitly request more detail when needed.
So you can dial up the detail level depending on task complexity.
Precisely. It gives you absolute granular control over the information density. We have covered a massive amount of technical ground today. We analyzed destructive command guard for intercepting dangerous API calls. We broke down how CanvasUI maps shader mathematics.
We looked at mapping animated UI components to React loading states.
Right. We explored no AI slop for adjusting token probabilities. And finally, I have ADHD for reducing cognitive load.
If we pull back and look at the macro picture here, a very clear philosophical theme emerges. These are not just random isolated add-ons.
They represent a fundamental shift in how we interact with these large language models.
Exactly. We are collectively moving away from simply accepting default AI behaviors. We are no longer settling for statistically generic templates, dangerous terminal freedom, or fatiguing robotic text.
We are actively, aggressively molding the intelligence.
Yes, we are transforming raw, probabilistic models into customized, incredibly safe, and highly efficient collaborators. We are building systems that actually respect human workflows rather than forcing humans to adapt to the AI's defaults.
It is about taking total ownership of the autonomous tools we use every single day.
These specific projects are completely free, they are open source, but their real underlying value is the preservation of your time and mental energy. They systematically eliminate the small, daily frictions that make AI exhausting to use at scale.
So take a hard look at your own digital workflow today. Which of these 5 specific friction points is bleeding your time the most? Is it the underlying fear of destructive commands? Is it generic, flat UI design?
Is it sludgy, predictable copy?
Or is it buried, over-explained answers?
It raises a deeply important question for all of us building in this space. If we have to build complex open-source middleware just to make AI act more naturally and efficiently, what does that actually tell us about the default design of AI systems today? Are we endlessly adapting to the AI, or is it finally time we force the AI to adapt to us?
That is something definitely worth thinking about. Thank you for joining us on this deep dive.
Stay curious.